Today, we are going to be discussing robotic arms. Let's get right to it. Now, before we talk about the potential and parts of a robotic arm, let's take a look at the mini robotic arm that I built. This robotic arm has 6 different ways that it can move. It can transport materials even though it is very small. Imagine what a large-scale robotic arm could accomplish. Robotic arms will revolutionize almost every job in the future. Most robotic arms have 6 axes. This means that they have 6 degrees of freedom or ways that they can move. Degrees of freedom is very important. The more a robotic arm has, the more maneuverability it has. Robotic arms were created with 6 degrees of freedom because human arms also have 6 degrees of freedom. This means that these 6-axis robotic arms can do any job or task that humans can, whether it's welding, laying bricks, or packaging simple items. There are different types of joints that make up these robotic arms: linear, revolving, orthogonal, and twisting. Now, before we start talking about the different types of joints, we must first understand what a link is. A link is the part of the robot that the joints connect. Now, back to the types of joints. First, we have linear joints. In linear joints, the motion between the input and output link is a linear sliding motion. In revolving joints, the joints allow rotational relative motion between the two links, with the input link parallel to the axis and rotation of the joint. The output axis link is also perpendicular to its axis rotation of the joint. Next, we have orthogonal joints. In this type of joint, the axis of rotation is perpendicular to the axis of the output and input links. Lastly, we have twisting joints. In this joint, the axis of rotation is parallel to the axis of the two links. Thus, the joint can be twisted in a 360-degree motion. Now, how are these robotic arms actually programmed? Well, there isn't one specific language. They can be coded using Python, C++, or even MATLAB. Now, these are just some sample languages, but there are a ton more that can be used. Now, this code that is used needs to be understood by a computer so it can carry out the actions it was programmed to do. The only code computers can understand is machine code. Machine code is a set of binary instructions. This is a set of ones and zeros typically combined into groups of 8 called bytes. These bytes are then converted into sequences which the computer can interpret. Now, these high-level languages, such as Python, C++, or MATLAB, are put through a compiler. Once the code is run through the compiler, it comes back out in the form of machine code, allowing the computer to interpret it. There are 5 main parts to a robotic arm: the controller, the sensors, the arm, the end effector, and drive. The controller acts as the brain of the arm and instructs it how to operate through code. This code is then sent to the CPU, or central processing unit, in the robotic arm, which then processes the code. The second part of a robotic arm is the sensors. These include the vision system and microphones, which allow a robot to see and hear its surroundings. Next, we have the arm. The arm supports the claw of the robot. Fourth, we have the end effector. This is typically at the end of the robot and is attached to the end of the arm. In most cases, the end effector is a claw and transports materials. Lastly, the drive is the motor of the robot, meaning that it powers it. Robotic arms created today are very expensive and are mainly focused on completing one single task. Now, let's take a look at cobots, or collaborative robots. These robot arms allow humans to safely work with the arm to complete tasks. They are also cost-effective, easy to program, and are very flexible with new products they may come across. Basically, cobots reduce physical workloads on humans, and they still maintain a safe environment. Over 46,000 of these have already been sold, and this number will just continue to grow. If you think cobots are cool, let's take a look at Flippy. Flippy can work a fryer or a grill and can consistently cook burgers and fries perfectly. It also has automatic tool swapping, is washable, and works with other kitchen staff. It uses artificial intelligence thermal sensors to detect whether or not the meat has been cooked thoroughly and properly. These types of cobots are already being integrated into places such as Cali Burgers in Pasadena and at White Castle fast food chain restaurants. Who knows? Maybe in the future, all of us will have a Flippy in our very own kitchen. Thank you for listening, and if you enjoyed this video, please subscribe.